So in this lesson, we're going to look at systems of equations, and specifically these are quadratic linear systems. So we did a little bit in Unit 1 with just linear systems where both equations were linear, and we're also in this lesson going to talk further about using graphs to solve equations. So in this first problem, which I have the work done, basically we have a system of equations, or two equations with two variables, and y plus 8 equals x is my linear equation, and y equals x squared minus 2x minus 8 is my quadratic equation. So the first step you want to do is solve for x or y in one of these equations. And basically, the method we're usually going to use is just to solve for y on both equations. So here, my quadratic equation is good. My linear equation, I need to move over the 8 to the other side, which is going to give me y equals x minus 8. From there, the two y equals, I'm going to set equal to each other. So we have x minus 8 equals x squared minus 2x minus 8, and we get down to here. Now, if you could cover up what I just pointed to, this equation we have here is the same as from 2 lessons ago when we were solving using the zero product property. So I bring everything over to one side, which in this case is going to involve subtracting the x and adding the 8. And I end up with x squared minus 3x equals 0. I set it equal to 0 because it is a one variable quadratic equation. From here I factor, this is just a nice GCF, so I get my two answers. I get x equals 0 and x equals 3. So this piece of the problem here is could have shown up in that previous lesson, but we're adding the systems piece, so we don't just find x's. Since my original equations started with x and y, I have to go and plug in those x values, plug in the 0 and the 3 to find the y values. So when I plug in 0 here, I get negative 8 when I solve, and when I plug in 3, I get negative 5. So here I have 2 points, 0, negative 8, and 3, negative 5, and those are my two answers. So moving down the page, we're going to try a system. So neither of my equations are solved for y. I'm actually going to solve both of them. So I'll write the quadratic one right here. So I have x squared minus 4x equals y minus 3. So the easiest way to get y by itself is just to add 3 to both sides. And I get y equals x squared minus 4x plus 3. For my linear equation, I'm going to put that over here. I have y minus x equals negative 1. So I'm just going to add x to both sides. And I get y equals x minus 1. So from here, I have two y equals. I'm going to set what y equals equal to each other. So I'm going to set x squared minus 4x plus 3 equal to x minus 1. From there, I am going to set it equal to 0 because we have a quadratic. We have that x squared. And we get x squared minus 5x plus 4 equals 0. And from there, I'm going to factor. And I get x minus 4, x minus 1. For my factors, things that add up to negative 5 and multiply to 4. So my two answers are 4 and 1. Now, remember, if it was a one variable equation to start out with, we would be done, but we need to find the y values that go with those x values. So I'm going to move over here, and I'm just going to rewrite those x values, and we're going to plug them both in to my easier equation. Really, either one is fine, but the easier equation is the linear one. So I'm going to plug them into this equation. So I have y minus, in this case, 4 equals negative 1. When I add the 4 over, I get y equals 3. And in this one, I get y minus 1 equals negative 1. So when I add the 1 over, I get y equals 0. So this is going to give me 4, 3 is my first point, and 1, 0 is my second point. So pairing them up, these are coordinates. These are coordinates that go together. So you might think that you have like 4 answers here, but there are 2 answers that are ordered pairs. So that's why I have to write it that way. I can't just like randomly list out the 4 different numbers I got.